Any progressive finite element analysis must understand information about the global loads and environment, which affect the stress and strain distribution through the structure. Typical progressive failure analyses work at the composite lamina level, where each element is assumed to represent the material, such as this unidirectional composite. Once the lamina information is known, decisions are made at the lamina level as to how to initiate and propagate damage, which in turn is fed back to the element of the finite element analysis. The finite element analysis then takes this information and forms the global response to the structure. This can be repeated as often as necessary for a structural simulation. Autodesk Helius PFA uses a multiscale approach to initiate and propagate damage by working at the fiber and matrix level. The fiber and matrix information is acquired and generated with minimal impact to both the user and the finite element analysis. Using information at the constituent level more accurately represents the failure mechanisms of the composite material. Autodesk Helius PFA also forms the response of the constituents to drive the response of the composite, which in turn feeds back to the finite element analysis through traditional methods. For chopped fiber materials, Autodesk Helius PFA acquires the fiber and matrix information through a Mori-Tanaka decomposition to perform plasticity calculations and matrix cracking calculations at the matrix level. The response of the composite is then built back from the constituent information to feed the analysis. Similarly, for unidirectional materials, Autodesk Helius PFA can acquire the fiber and matrix information and form the response of the composite material efficiently and accurately by identifying and propagating damage at the fiber and matrix level. Finally, for woven materials, the fiber and matrix information is easily acquired during a finite element simulation for both the fill and warp toes using the capabilities embedded within Autodesk Helius PFA. The response of the woven material is reformulated by identifying and propagating damage at the fiber matrix level, which in turn is used to define the response of the composite material. Working at the fiber and matrix level allows various modes of damage to be identified in either toe, which will result in different responses of the composite material in the finite element analysis, resulting in physically realistic damage propagation.